Welcome to this very first Q&A session to Competitive Strategy. First of all, let me say thank you to all of you for being part of this experience, for watching the video lectures, for doing all the quizzes, and most importantly, for taking part in the discussions in the forums. We're really overwhelmed by the great discussions and by your thoughts on the various topics. Thank you also for all your suggestions about further improvements of how to make the course even better. And thanks also for letting us know about bugs in the videos and in the quizzes. We really appreciate your support in improving the course. I also want to apologize that it sometimes takes us a while to answer your questions in the forums or fix some bugs in the videos and quizzes. Thanks a lot for being so patient with us. So we checked the forums to identify a couple of questions that were discussed fairly frequently by many of you. And so what we want to do now is give you some detailed answers to these questions and dig a little deeper into some of the course content. So as always, sit back, relax, and listen. Okay, so let's get straight into things and let's take a look at some of the questions that you asked in these last couple of weeks. So we're going to have some questions from sessions 1 and 2 especially, but also we're going to look at week 3 to clarify one or two things. Okay, so starting with the first question, one of the issues that really troubled you or that really made you think was the question of how we get these payoffs, right? So after all, game theory is only useful once you start having these payoffs, once you start thinking about what firms actually want to do, and they want to do whatever maximizes their payoffs. Right? And there were some very lively discussions, very interesting discussions, I think. And let me now give you some strategies of what you need to do or what kind of information you need to actually analyze games like that. Okay? So you'll remember from week 1, this game with the sequential game where we were looking at Chocolate Wars, right? So the issue here was about E.T. E.T. was given a couple of candies, and the question was which kind of candies. Okay? Universal Studios, the maker of E.T. at that point, offered a product placement to a number of firms, Mars and Hershey's, and they charged $1 million for it. If Mars had accepted the deal, their gross profits would have increased by $800,000, and Hershey's would have decreased by $100,000. If Hershey's accepts the deal, which is actually what happens, or what happened in reality, Hershey's gross profits increased by $1.2 million, and Mars's profits decreased by $500,000. If none of the two firms agrees, then it's business as usual and no change in profits occurs. Okay, so you will remember that game tree, and you know again here that Mars faces the first choice of either signing the deal, the game ends, and Hershey's basically has nothing to do, or not accepting the product placement, and then Hershey's gets to choose if they want to accept the deal or not accept the deal. Okay, and we know what the payoffs are. If Mars accepts the deal, then they pay $1 million and they get extra profits to the tune of $800,000, so their net profits are going to be a loss of $200,000. Hershey's loses $100,000 because they lose a bit in competitive position. If business as usual happens, then we end up with a profit of 0 for both. And if Hershey's accepts the deal, then they pay $1 million, they make extra profits of $1.2 million, so their net profits are going to be $200,000, whereas Mars loses to their strongest rival, loses quite a bit of market share, and they lose profits, or their profits go down by $500,000. Okay, so far so good. We all know how to solve this if the game is clear, if we know exactly what the payoffs are. But let me now give you a couple of techniques of how we can relax the kind of information we have and still make informed decisions. So let's see. So first of all, we can imagine a situation where we don't know the exact value. So for example, Hershey's might get payoffs of 1.1 million or 1.3 million. Now, how does that change Mars's behavior? How does that change Mars's look at the situation? So Mars again faces that choice. Do I sign, do I not sign? if they don't sign, and if Hershey's accepts the deal, then what changes if we don't know the exact number here is the 0.2 million, right? This could be 1.1 minus 1 million, that's 0.1 million, or $100,000, or it could be 1.3 minus 1 million, so that's 300,000. Still, of course, on average, it might be 1.2, but it's not exactly that. How does that change the deal? How does that change the game? Well, interestingly, it doesn't change things one bit. Why is that? Well, Mars doesn't care about the exact profits that Hershey's makes. Mars only cares about whether this value is above 1 million or below 1 million, right? Because what they care about is Hershey's behavior, not Hershey's profits. And Hershey is going to behave exactly the same regardless of whether the profits are 1.1 million or 1.3 million. In both cases, they're above 1 million. So they always should accept the deal. Therefore, Mars should always try to foreclose the deal from Hershey's, right? Because otherwise, if they get the choice, they would accept it. So therefore, both values are above 1 million. Hershey's will always accept, and therefore it's best for Mars to accept the deal themselves, right? And lose 200,000 rather than losing 500,000, which is what exactly would happen if they gave the choice to Hershey's. Okay, so far so clear? Let's take out some more information. So let's take out information about whether Hershey's gets above or below 1 million if they accept the deal. Right? So to keep things simple, let's just say that with 50% probability, Hershey's gets a payoff of above 1 million, in which case they would buy. And with 50% chance, Hershey's gets a payoff of below 1 million, in which case they would, of course, reject the deal that they were offered by Universal. So how does that change? Well, again, this number is what changes, right? If it's above 1 million, then this is going to be B minus 1 million. And if B is above 1 million, then this number is positive. If B is below 1 million, then this number is negative. And of course, in that case, we would be better off not accepting the deal, because that leaves us with 0, rather than accepting and getting something that's below 0. Okay? So, in other words, if we look at this, if we know that Hershey's gets above 1 million with 50% and below 1 million with 50%, we can take what's called the expected payoff, right? We don't know the precise payoffs anymore, but we can take the expected payoff. So the expected payoff for product placement, right? For product placement, for leaving the product placement to Hershey's, to Mars, is minus 250,000. How do we calculate that? It's losing $500,000 for all cases where the payoff to Hershey's is above 1 million, and getting 0 if the payoff to Hershey's happens to be below 1 million, because in that case, Hershey's would be better off not accepting. Right, so we've got 50% times minus 500 and 50% times 0, so that leaves us with minus 250,000 in expected terms if Mars does not accept the deal, right? So if they leave the decision to Hershey's. Now, of course, if they accept the deal straight away, if Mars decides to end the game already, then we know that they would lose 200,000, right? So they pay 1 million, their profits increase by 800,000, so we're left with minus 200. So that means that comparing minus 0.2 and minus 0.25, it's actually optimal again for Mars to accept the deal, right? To foreclose the likelihood or to foreclose the risk of Hershey's possibly signing the deal. Okay, so you see what we're doing. We knew what the payoffs are to begin with. We then said, well, we know they're above 1 million, but we don't know exactly what they are. So we had two values, and we could still make the same analysis. We then said, well, it could be above 1 million, it could be below 1 million, and we calculated what's called the expected value. Okay, and the expected value then was the one that we could compare with the payoffs that, that Mars would get if they signed the deal straight away. Still with me? Let's have another look, and let's take out even more information. So what we had previously was knowledge about the fact that 50% of the time, or with 50% likelihood, we're above 1 million, 50% of the time Hershey's is below 1 million. Let's now take away even that piece of information. So now Hershey's gets a payoff of above 1 million with a probability of P, and that P could be any value between 0 and 100%. And they get payoffs of below 1 million with a probability of 1 minus P. Right? So we're now really in the zone where we don't know a lot about the payoffs of our competitor. Now, again, we have this payoff matrix, but we still have to figure out, again, if this is above or below 0. And once we've got that, we can then calculate what the expected profits are for Mars. Let's have a look. So here, taking this, we can find that the critical probability is 40%. Now, what does that mean? The critical probability of 40% means that if the likelihood that the payoffs of Hershey's are going to be above 40%, are going to be above 1 million, is more than 40%, then Mars should accept the product placement. If they are below 40%, they would not accept the deal. So, of course, you might ask, well, where do we get this 40%, right? Not very differently from what we just did before. So we can actually calculate the expected payoffs here. So we have P times, if Hershey's gets payoff of above 1 million, that means that they would accept the deal, and Mars would be left with payoffs of minus 500,000 or minus 500,000. That plus 1 minus P, that's the likelihood that Hershey's gets a low payoff, and in that case they would not accept the deal. So that would be 0. Now what do we compare that to? We don't compare that with 0, we compare that with the value that Mars would get if they accept the deal straight away. And that's going to be minus 0.2, minus 200,000. Right? And so if we then look for the value of P, that actually puts these two exactly equal, right? So we put P times minus 500,000 plus 1 minus P times 0 has to be equal to minus 200,000 to minus 0.2. And that is then the probability, the critical probability of 40%. And you can think about this intuitively. It's fairly intuitive. So if the likelihood that Hershey's has a high payoff from accepting the deal is fairly high. So if P is fairly high, let's say it's 100%, right? Let's say it's 80%. In that case, Mars is almost certain that if they don't sign the product placement deal, then Hershey's is going to sign it, and Mars is going to lose 500,000. So on the other hand, if the likelihood is very low, right? So if, let's say there's only a 10% chance that Hershey's actually would want to sign the deal, then it's better for Mars to take their chances, right? So they would say, you know, chances are so low that Hershey's is going to accept the deal, so we're going to take the risk because we're better off getting 0 if we don't sign and Hershey's doesn't sign than losing 200,000 for sure. Okay? So here, this critical value of 40% is the critical likelihood that separates our expected payoff, the expected payoffs of Mars, between signing the deal and making minus 200,000 and not signing the deal, and then running the risk of Hershey's accepting and I lose 500,000, or not accepting and I lose nothing. Okay? So that's, again, relaxing some of the information, right? So again, let's take a step back. We started out knowing everything. We said clearly this might be unrealistic. So we said, well, let's now take two values. And we assumed two values above 1 million, and we found that it's not at all relevant if it's 1.1 or 1.3. Hershey's is always going to behave in exactly the same way. Now, if we then take one step further and we say, well, we don't even know if it's above or below 1 million, we can take the expected payoff. And we found that if it's 50%, the expected payoff is actually more negative from not signing the deal for Mars than from signing. And then we said, well, we don't even know the probabilities, and that gave us a possibility to find this critical value of P. And now let's go one step further and say, well, we don't know anything. We don't know any numbers, right? All we know is that we get some payoff if we sign and Hershey's does not sign. We get some payoff if we don't sign and Hershey's signs. And of course, Hershey's always also gets some payoff as well. Okay. Now, what we can do with just a ranking, with just some general information about these possible different outcomes, is we can actually retrace the values that have to have led to an outcome like this, like the one we saw. Okay. So, for example, let's take this. This outcome. Let's take the outcome that we saw in real life. In real life, we saw that Mars did not sign the deal, and we saw that Hershey's accepted the deal. Now, what are the restrictions that we can see or that we can derive from this outcome? Okay. Again, we have to realize that both firms behaved rationally. So here, we know that Hershey's must have preferred signing the deal to not signing the deal. Now, what does that mean for our payoffs? It means that our payoff of D, or Hershey's payoff of D, must be bigger than Hershey's payoff of F. Right? So D must be bigger than F. That's one restriction. The other restriction is that Mars, if they behaved rationally, they must have preferred no product placement and accepting that Hershey's is going to sign the deal to signing the deal themselves. So that means that A had to be smaller than C. Okay? So if we want to rationalize an outcome, if we observe behavior in reality, then we can derive from that, not using any numbers, right? So if we assume we don't know these numbers, we can derive from the outcome what some of these numbers have to have been, or how they relate to each other. So in this case, if we take the numbers that we had before, A was actually minus $500,000. No, that was, that was minus 200,000, and this was minus 500,000, right? So in this case, this condition is actually not met because minus 500 is actually smaller, so it's more negative than minus 200,000. So this method, right, this ranking method, is actually useful if we want to rationalize ex post what the payoffs must have been. Okay, so I hope that clears something up. Of course, do keep on discussing in the forum of how you can get some of these numbers. But just to make clear, you can get by without knowing all the information, right? But after all, if you work in a large company, then by all means, speak to your market research department. Every large company will have some department that does competitive analysis, that tries to find out stuff about their competitors, and this is what usually gives us the numbers here. Okay, good. So much for these payoffs. I think this was an excellent question and a couple of excellent contributions to that, and I really wanted to make sure that you know how to make the sometimes abstract concepts more useful for yourself in practice.